okay? It's not in the way. It's okay. I've turned the screen around. So then I can show Lois I try to focus. Right? Okay. So far we have looked at price output determination in a monopoly. Okay. So go back. This is the average revenue curve. This is the marginal revenue curve. This is the marginal cost curve. This is the point at which marginal cost equals marginal revenue. This is the quantity. We have price on this axis, quantity on this axis as usual. So this is the price. Okay, this is the consumer service. Sure. Okay. Right. So now, so what is the monopolist doing here? He's selling at P to all consumers. Okay. He's selling at P to all consumers. So if you look at the person buying the first quantity Q1, this person actually gets this much of a consumer service. Right? The person buying Q2 actually gets this much of a consumer service. And so on. So the marginal consumer, okay, the marginal consumer, that is the one who buys the quantity Q star, is the one who has no consumer surplus left. Okay? And then we argue that this actually is the deadweight loss of monopoly. Right? Now, assuming that the monopolist is a profit maximizing monopolist, can the monopolist do any better? Can the monopolist do any better? Look at this graph and tell me if the monopolist can the monopolist do any better than this? He's getting a price P, right? That is his total profits. His total profits are this, right? This range is the, so this is price minus marginal cost. This whole area is the monopolist produces surplus. What is price minus what it costs to produce? The price minus marginal cost into the total quantity sold. Right? Can the monopolist do any better? Is it louder?
If you know the willingness to pay of each consumer, we charge them at like Q1 at that time and then take the
So, if the monopolist knows the willingness of each consumer to purchase the commodity, what he can do is, you have the demand curve, you have the marginal revenue curve, the average revenue curve, the marginal revenue curve, you have the marginal cost curve, right? So instead of selling at P QM, what he can do is he can charge the same price to all the customers, PC, right? Sell the quantity QC, but for the first person, charge a tariff equal to this quantity. Charge a tariff equal to T1 for the first customer, right? Charge a tariff equal to T2 for the second customer, and so on and so forth, right? So no consumer is getting any consumer service, right? The price and the quantity is what will be produced under perfect competition, where the marginal cost curve, this is a supply curve and this is a demand curve, where they intersect. That would be the price, right? So that will be the quantity C. PC will be what will be produced, but unlike in a perfect competition, this whole thing will not be consumer service. What happens is, the first consumer will actually pay a tariff equal to equal to T1, tariff T1, which equals that consumer's willingness to pay. The second consumer will pay tariff equal to T2, which equals that consumer's willingness to pay. It is the last consumer, the marginal consumer will not be paying any tariff or a fixed cost, right? A fixed fee to enter into a transaction, right? Because he'll just be paying, he's just paying his willingness to pay, right? So the monopolist will be able to extract the entire surplus by doing the first degree price discrimination if he knows the willingness to pay of each player, right? Each buyer. But this is a strong assumption, isn't it? That the monopolist knows the willingness to pay of each buyer is a rather strong assumption, right? Okay? Because the monopolist might, for example, know that a business class for traveler has less freedom to choose his flight schedules, whereas a leisure passenger can actually then reschedule his flights for the cheapest flights and all that, right? And therefore you can charge a different price to a business traveler and a different price to a leisure traveler. But when somebody calls in to book a ticket, the airline doesn't know whether that person is a business traveler or a leisure traveler. So what the airline can then do is, it can actually charge, it can create. So what it does is, it then, so it can't do first degree price discrimination. It doesn't know whether the caller who is called you, the monopoly doesn't know the willingness to pay of each and every person who wants to buy the product. So what does the monopolist do? Any idea? What a monopolist can then do is design price and quantity packages, right? A certain quantity at a certain price. Okay, so two different price and quantity packages which are designed in such a way that buyers will automatically self-select. That is, the business class travelers will take the package meant for them. The leisure travelers will take the package meant for them. Right? So the key idea is to really create, develop packages which will lead to customers self-selecting, which is called second degree price discrimination. Okay, so what's the difference between the first degree price discrimination and second degree price discrimination? Yeah, can somebody tell me the difference quickly?
First degree price.
Actually, go ahead, tell me what it is.
So in the first degree price discrimination, he knows each player's willingness to pay. Whereas in second degree price discrimination, he makes two packages and each player chooses for himself which appeals to him more.
That's the idea, right? Because he doesn't know the willingness to pay of each player.
Yeah.
Right? Okay. So what we'll do today is to have a quick formal treatment of the two. Right? A formal mathematical treatment of first degree price discrimination and second degree price discrimination. Right? Yeah. So okay, so let's make some assumptions. There are two types of buyers, N1 and N2. There are two types of buyers, N1 and N2. Right? So we say, what distinguishes the buyers? Their utility functions. Okay, we'll write utility functions as specialized utility functions. We'll write UI, utility function of the I buyer, is UI xi plus yi. Right? UI xi plus yi, where I 1 to 2, right? So both types. Where X is a monopolized good and Y is a composite for all other commodities in the economy. Right? So what, see, because customers are actually substituting between monopolies. For example, when somebody decides to go by the airlines, he actually has the option of going by trains and all those kinds of things, right? So all the non-monopolized goods will write as Y. The monopolized good is Xi. And this is a special kind of a utility function known as a quasi-linear utility function. Okay? Known as a quasi-linear utility function. Okay? Right? How do these indifference curves for the utility function look? See, the first property will be, think of dui is equal to ui dash xi dxi plus dyi, right?
Yes.
Because the derivative of y with respect to y will be 1. So if you look at the slope of this, okay, the slope of this is minus ui dash xi, okay, is equal to dyi by dxi. Do you think they're a little bit different from the slope of the standard indifference curve? Do you think it's a little bit different from the slope of the standard indifference curve? What is the slope of the standard indifference curve called? Yeah. So what is that ratio equal to? No, what is that ratio equal to? Marginality of 1. What's the marginality of substitution? Ratio of marginality of x and y. But here do you have the marginality of y? No. Right? Okay. Secondly what? So therefore, how the indifference curve is going to look like? So if you have, for example, type 1 and type 2, right? The one with the higher marginality is going to have a steeper indifference curve, right? Sure? Okay. And the indifference curve you can make out, therefore, will look like this, right? The indifference curve will be parallel shapes. Yeah? You see why the indifference curves for the same individual will be the kind of parallel shapes with each other? Can you tell me why? So if you take a utility function of this kind, indifference curves for the same individual will essentially be parallel shifts of each other. In general, indifference curves are like this. Have you know? In general, you know that the indifference curves are like this, right? Okay. But in this case, in the utility function of like this, indifference curve, the indifference map will look like this. Can somebody tell me why? I'll call this, say, IC1, IC2. So what's the slope of the, okay, so can you tell me why they look like this? Yeah. No, but can you, does it provide a key to you? For x equal to 0, what is the slope of the indifference curve? So suppose for example, we think of this ui xi, suppose we think of this ui xi as xi raised to alpha, for example. Right, so think of some indifference, some function, right? So what will you have for xi? Alpha xi raised to alpha minus 1. And so let's say, think of this, right? Right. So alpha minus 1 will be, so suppose alpha is equal to 0.7. So minus 0.3.
Yeah.
So this will be alpha upon xi raised to 0.3.
Yeah.
Right? So 0.3 upon xi raised to 0.3.
0.7.
0.7. So you're at 0.7. 0.7 into xi raised to 0.3.
Yeah.
Right? Now, what will the slope of this if xi is equal to 0? undefined, right? Infinitely large. If xi tends to 0, the slope will be infinitely large, right? Okay, so xi is equal to 0, this will correspond with the y-axis. The y-axis has an infinite slope. Right? Okay, so you get something like this. And as xi increases, obviously the slope will go like this. Right?
Can you repeat that, the last bit again, sir?
See, the closer xi is to 0, the closer is the slope to infinity.
Yes.
So asymptotically, as it tends to 0, this slope will approach the y-axis.
Okay.
Right? If x is equal to 0, right? Okay? But obviously, a higher level of y will mean the indifference curve starts at a higher point on the y-axis. If x is equal to 0, right? You want to get the same indifference curve, right? Okay, so indifference curves for the same individual will actually be parallel displacements of each other, right? Okay. For the different individuals, okay, right? For different individuals, the one who has a higher preference for the good, that is, who has a higher margin utility, will actually have a steeper indifference, right? Because the slope will be higher, right? Is this clear? They are called quasi-linear utility functions. So we'll assume that buyers of type 2 have a stronger preference for the good. So the ones with a steeper indifference. Right? Okay, this is the first assumption that you are making. Okay. All the buyers have an identical income of M. Yeah? We'll assume that if you don't consume anything, you get zero utility. Right? If you don't consume anything, you get zero utility. And utility increases at a decreasing rate. We'll also assume that the price of the monopolized good, because we are not interested in the price of the non-monopolized good, is 1, and the price of the monopolized good is P. Because we are not interested in the non-monopolized good, right? And if you have quasi-linear, the utility functions, it can be shown that the income effect is 0, right? So the price of the non-monopolized good changing, and then so we can then safely say we can keep the price of the non-monopolized good at 1. Okay, is clear? Sure. Then the problem that we have to solve is so let's first look at first degree price discrimination. We'll assume that structure. So what's the consumer's choice problem? Can you tell me what the consumer's choice problem would be? Maximize utility. So maximize u of xi, choose over xi yi is equal to ui xi, okay, max over yi, ui xi plus yi, right? Because I can choose x and y to maximize this. Subject to P is the price of x, 1 is the price of y. So, what will be the constraint? Yeah, so Pxi plus yi m minus, let's assume that the consumer of type I has to pay a fixed cost tariff called Fi to enter the transaction. Right? Because we showed that. No? So P of xi plus yi less than or equal to m minus f. Okay? So what will be the Lagrangian for this? Can you tell me what the Lagrangian will be? Yeah. Yeah.
Over here, we are assuming there are going to be different prices for different quantities of the commodity.
No. We are assuming in the first degree price discrimination you charge the same price but charge different fixed costs.
Okay.
Entry. So you charge a different FI to each type of consumer.
Okay. But
Right.
keep the price.
Yeah. So what is happening? This picture was like this, right?
Yeah.
So we say we charge the same price to everybody,
Okay.
P, but the first consumer we charge F1. For the second consumer we charge F2 and so on and so on.
Okay.
That's the kind of a problem.
Yeah.
So the P is constant.
It is the same. Everybody gets the product at the same price, but everybody, each consumer pays a different tariff, right? A different entry fee kind of. Right. So think of going to an amusement park. So once you enter the park, you have to pay the same thing for everybody pays the same price for the rides, but different people pay different entry fees to enter the amusement park. FIs are those fixed entry fees, right? Okay. So what will be the Lagrangian? Can you tell me what the Lagrangian will be? Plus lambda into
n minus phi
right? Okay. So now differentiate, no? What do we differentiate with respect to? Xi. So what are the first set of conditions? U dash I xi. What do you get then?
minus lambda.
Is equal to 0, right? And then you need to differentiate also with respect to y. You need to differentiate also with respect to y, right? And then of course with respect to lambda. What do you get with respect to yi?
1 minus lambda.
Right? So do you get something insightful right away? So lambda is equal to 1. Yeah? If lambda is equal to 1, what do you get? You get ui dash xi is equal to p. Right? Sure? Ui dash xi is equal to p. Right? So we can write xi as, how do you get xi? You get xi as ui dash inverse of p. You can get xi as ui dash inverse of p because you know now, what are you saying? We are saying that marginality of x is equal to p. Right? So higher the p, higher should be the marginality of x, which means lower must be the consumption of x. So for every p you can find a corresponding x. See what this rule says. This rule says that higher the p, higher should be the marginality of x. Right?
Yes.
When will the marginality of x be higher? If you consume less x. So with every p you can find an appropriate x. So you can write x as a function of p. Right? This is what I've done. I've inverted the marginality function, right? And written xi as a inverse function, right? Ui dash p. Okay. Right. So what will be yi? What will be the value of yi? So yi must be equal to m minus fi. See, lambda is equal to 1. If lambda is equal to 1, the constraint must be satisfied with equality. Right? So it must be true that in equilibrium the constraint is like this. Satisfied with equality. Right? So from which it follows that yi is equal to minus p of xi. Yi is equal to m minus fi minus p of xi. Right? From which it follows, now all this can go, from which it follows that we have, so I have xi,
So it's plus.
Y
Yeah.
should be plus.
Y should be plus.
right? Okay. Now, can you tell me what will be the indirect utility function? Can you tell me what will be the indirect utility function?